Hey everyone, a couple of so let me know if you guys can hear me properly, if I'm audible, and also yeah, like also let me know how was the contest, how were the questions. Let me know if you guys can hear me. That audible, okay. Thanks. Thanks for letting me know. Okay, so how was the contest? How were the questions? Like, you guys like the questions? Like the questions? How were the questions? Please a bit louder. Okay. Now is it better? Let me know if it is better. Let me know how was the contest. Did you like the problems? Were the problems easy? Were you able to solve it? Uh, Overall, like, how do you think the contest went? I see. Okay, 371 submissions for the hardest problem, and oh, this is very close. Smaller sum and make palindrome are pretty. Yeah. एक भी नहीं बना. I'm so demotivated. It's totally fine. I'll discuss the solutions. Just make sure that after like once you watch the session, try to write the code yourself, and again, like it will come with practice, right? Rank 5 here. Last one is famous job seeker from lead code. Okay. Yep. I didn't get 3, but it was a good problem. Okay. Sure, we'll discuss that as well. No worries. That's true. Okay, so let's start discussing the problem. So first problem, make palindrome. So it is said that you are given an array of strings ARR of length n, right? You have to find out if it is possible to make a palindromic string by concatenating the strings in any order, provided that all the strings given in the array are of equal length. Okay. Did we need to use greedy or Dijkstra? I tried greedy, I couldn't get it. So the last problem will be a DP problem. Could solve only two. So let's solve. No worries, no worries. Let's look into the solutions. Okay. So okay, so it is said that you have to create, you have to concatenate. You are given a array of strings, right? You are given an array of strings. uh, each string length is equal. You have to concatenate them in some way. You have to tell whether it is possible to concatenate them in some way such that the resultant string is a palindromic string, right? It is a palindrome. For example, you are given 4 strings here, dj, fa, ga, dt, this and this. You can actually concatenate them like this, that these two and these two, and you will get the overall string, that is yeah, dj, fa, ga, dt. So if you see, this is a palindrome, right? Like, just see from the first and the last, this is a palindrome. So there is a way to concatenate them, so we'll report yes, right? Similarly, there is no way to concatenate them such that it is a palindrome, so we'll report no. So this is the question, right? So you are given n strings, and you have to report whether you can concatenate them in some way so that it is palindrome versus not palindrome. Okay, so let's understand this. So the first thing that makes the question easy is basically, it is said that all the strings are of equal length, right? So all the strings will be of equal length. Now let's consider 4 strings, right? S1, S2, S3, S4, and all are equal length. We want to tell that their concatenation is palindrome or not. So what does that mean? That means each one of them, okay, each one of them should be a reverse of another. They should be a reverse of another because all are of equal length, right? So if you add something, let's say you add S1 somewhere, and let's say S4 is the reverse, so S4 should be added in the corresponding place from the end, right? So for each string S1 there should exist a S4 which is a reverse. So that brings us to the first thing, that is for each, not for each, for strings their reverse should also exist. Their reverse should also exist, right? And that actually solves the question, that actually solves the problem for even number, right? But for odd number it will not solve the problem. Why? Because what is the odd number? Like let's say you have three strings S1, S2, S3. What will be the corresponding resultant? Let's say this is a palindrome. Now if you see S1 and S3 all are of equal length, right? All are of equal length. So S1, S3 must be the reverse of S1. S3 is equals to the reverse of S1. And S2 is in the middle. So S2 should also be a palindrome. So S2 should be a palindrome. Only in that case S1, S2, S3 can be a palindrome, right? So these two conditions actually help us identify whether you can form or you cannot form. So what is the overall condition? What is the overall condition? The overall condition will be should all strings must have palindrome in the given. Okay, so let me know if you have any doubts on this. So basically again, so the condition will be, first is if so all strings have their reverse, then it is a palindrome, then answer is yes. Second is at max one string does not have its reverse. At max one string does not have its reverse and it is palindrome, and it is palindrome itself. In that case that will become the middle element, like S1, S2, S3. S2 should be a palindrome in itself. So that will, these two will be the condition, and this will also result in yes, otherwise the answer will be no, right? So this is the question, right? So this is the question. Map, yes, map will be a easier way to do this, and in fact we'll also use map only. So let's try to write the code for this. Okay, so first is we'll maintain the we'll maintain if each of them is present or not. So what we'll do is, let's sorry, okay, so first is we'll maintain a map of the elements. So basically to check if the reverse exists or it doesn't exist, so string to bool is present, right? Is present, or you can use a normal map as well. So for string S belongs to ARR, is present S is equals to true. Okay, is present S is equals to true. And after that what we want to do, also we'll have one more utility method. So let's create a utility method, bool is palindrome, and we'll take a string S here. We'll check if S is a palindrome or not. How do we check if S is a palindrome or not? So by default will return true, and if there is a mismatch will return false, right? That is, it should read the same from front and back. So for int I equals to 0, j equals to s dot length minus 1, s dot size minus 1, I less than j, I plus plus, j minus minus. If s of I is not equals to s of j, that is, if there is a mismatch somewhere, will return false, it is not a palindrome. Otherwise will return true, it is a palindrome, right? So this is a method that will check if the string is a palindrome or not. Okay, so firstly we'll maintain num reverse absent. We'll maintain a count of the number of elements whose reverse is absent, right? First thing we'll do that. Also string string possible palindrome, let's call it possible palindrome, if it exists, right, is equals to initially empty string. Okay, string possible palindrome if it is empty string. So now we'll loop through all the strings. For string s belongs to string s belongs to ARR, and what we'll do is we'll do a reverse of s dot begin, s dot end. We'll do a reverse of s and we'll check uh, if yes, if is present. Now if the reverse is present, that is present of s, then we'll do nothing. But if it is not present, if the reverse is not present, then we want to do something. That is, we'll do num reverse absent, its reverse is not present, so num reverse absent plus plus, and also we'll store it. So possible palindrome equals to s, possible palindrome is equals to s, right? Now if first condition is if num reverse absent is equals to 0, return yes. Else if num reverse absent is greater than 1, return no. So we are done with two things. Sorry, return true false. So it should be return true, otherwise it should be return false. Now it is the case when it is equals to 1, then the string which is not repeated, its reverse is not present, that should be a palindrome. So in that case return is palindrome, and here we'll pass the possible palindrome, right? We'll pass the possible palindrome. So if it is true, it will return true, otherwise it will return false. Okay, so that should be it. What's the question, bro? It is the first question of the contest. Is yeah. So anyways, this part is yes. Should this be yes? Let's same input. No, I think, let's see. Does, I'm confused about one thing. Reverse, does reverse to in place? Let's actually do a C out. Yes. Let's see. Does a reverse? If it does in place or if it doesn't. So SDH. Okay. Got it. So that should be it. Okay. Now let's see what went wrong with us. So first is we have marked the elements, and if not present, we have first reversed it, and if it is not present, we do num reverse absent plus plus and possible palindrome equals to s. And if it is present, we don't have to do anything, right? So we don't do anything. Now we check if num reverse absent is 0. Set, then reverse, then again insert the reverse of element. Eventually set size is n. Yes, possible. What about one of them? What about one of them is not there, right? So like one of them, it might not be. So it might be actually equals to n plus 1, because one of them's reverse might not. It should be a palindrome, and you are inserting it again, right? Yeah, that makes sense. Yeah, you can do like that as well. So you take a set and you insert in that, and you then insert the reverse as well of each of them, and then you check if the size is equals to n. That might work. So if num reverse absent equals to 0, return true. Else if num reverse absent is greater than 1, return false. That's true. Otherwise return if it is equals to 1, then it depends on if the middle element is a palindrome, right? And for palindrome we have this check I less than j, I plus plus j minus minus, return true. String bool is present, we are setting is present s to true. Num reverse absent is 0, possible palindrome is this. And if not is present, num reverse absent, so plus plus, and possible palindrome equals to s. Okay. So if it is greater than 1, then return false. Otherwise, if it is equals to 1, it has happened only one time. Else if num reverse absent is greater than 1, 0 greater than 1, only 1 is remaining, right? So that means it depends on whether it is possible palindrome, right? Its reverse is a palindrome, which is actually true. Like reverse will also be the same thing, it read the same from front and back, right? So that should not be a thing. No need to check is palindrome. If reverse is present, it is palindrome. No need to check is palindrome. If reverse is present, it is palindrome. Yes, so that comes here, right? If reverse, for everything that whose reverse is present, then they will become a palindrome. But here we have to check for this one, right? At least that if this is the middle element, its reverse should also be, it should be a palindrome, because that is coming in between, right? So that should be there. And have we done this code wrong? I equals to 0, j equals to h dot size minus 1, I less than j, I plus plus j minus minus. If s of I is not equals to s of j, return false, otherwise return true. I'm not sure where is this going wrong. No, this actually gave a wrong answer. I'm not sure where it went wrong. Let's check the input, right, where it is. Okay, so 9. Okay, it's 9 only, that's fine. Our output is yes and it should be no. So let's copy this part and let's figure out like what is going wrong. So let's copy this entire thing, my output, and let's also print cout. Let's add a few debug statements. Cout first is num reverse absent, right? Number of elements whose reverse is absent, let's print that. Second thing that we have to print is possible palindrome. So possible palindrome is also something that we should print. And then, so let's try to get the output. For duplicates it will fail. 0. Oh, okay, got it. Yeah, so there might be, my bad. So basically there will be 2 elements whose frequency, let's see which one, this one, this. So there should be at least ys. Yes, so see, this is the problem. Sorry, my bad. So this is the problem, and this is very interesting actually. Like what exactly happened here, let's understand this quickly. So let's say you have a string abc, you also have the string cba, but let's say you have two abc. Now in our case it will tell us for both the abc that cba is present, but cba is present only once to like make palindrome with one of them, right? So abc, cba will not form a palindrome. The answer should be no in this case, but we will give yes, right? So our frequency should also be matching. So instead of actually just storing if the element is present, we also have to store their frequency actually. It should not be this, right? So int and is present of s plus plus, right? And here if is present of s, and let's take it string temp equals to s, and we'll check if is present of s is equals to is not equals to is present of temp. In that case we will do this, right? So there might be something that there might be a duplicate for which this might cause problem if you just store the if it is present or not. So now this should give a no. Yep, this is giving a no. So we will just this part. Yes, we should maintain the frequency. We should have maintained the frequency. Yep, now it is working. So this is the solution, pretty simple, right? Let me know if you have any doubts on this. Let's go to the second question. Okay. So you are given, and also let's clear the whiteboard. Let's go to the second question, and let me know if you have any doubts with the first question. So you are given an array ARR of n integers. We have to reduce the frequency to. Why do we need to reduce them? Why do we need to reduce them? We just want to check if the frequency of the element is equals to the frequency of the reverse element. In that case, all of them will map up, right? If not, then in that case, can you go back to the first question? Tell me your doubt. What is your doubt? If you want to read the question, just go to the contest site and read the question. Yep, we don't need. Okay, smaller sum. So let's read this question quickly. You are given an array ARR of n integers. For each index I, you have to find the sum of all the integers present in the array with a value less than ARR of I. Okay. So this is pretty simple question, like at least to understand. You are given ARR and you have to find the sum of all the integers in the array that are less than ARR of I. For each I, you have to find what the sum of the integers that is less than ARR I. Can you give a summary of the first? You can always rewind and watch, but anyways, like you had an array of length n of strings. You had to tell, and all the strings were of equal length, so you had to tell whether concatenating them you would get a palindromic string, right? So how we solved it is, as all of them are of equal length, so there are two cases that can happen. First is each element has its reverse as well in the array, so they will be mapped properly. Basically, if it's the even length, then if the element and its reverse is also present, in that case they will map up and it will be a palindrome. Second is if the length is odd, in that case the middle element will not have its reverse, but the middle element should be a palindrome in itself. So basically that's what we are doing. We are maintaining the frequency of all the elements, and we are checking if the element is present and its reverse is also present. If it is not present, we are maintaining the count of those elements. That count should not exceed 1, and that middle element should also be a palindrome. So that's what we are checking. Just recap. Anyways, so we are given this array and we have to find for each I the sum of all the elements that is less than ARR of I, right? It's very simple, right? Like you have 1, 2, 3. Now how many elements are less than 1? 0, so 0. 2, how many elements are less than 2? 1, sum of elements is 1. For 3, how many elements? Sum of elements less than 3. 2 plus 1, 3, so 3. So 0, 1, 3 is the output, right? But it is not necessarily a sorted array that is given to you. So this is pretty simple actually. Yes, many of you already have done this. It is simple binary search and prefix sum. So what you will do is you will sort the array, right? You will sort the array in a different array. Definitely you have to store it in a different array. In the second array, you will sort that array. You will take the prefix sum on that array. Now from the first array, for each I, you will find what is the position in the sorted array, right? And you will find the sum of the remaining elements from the prefix sum easily, right? So for example, let's quickly take an example to understand this better. So let's say you have 2, 3, 5, 1, 4, 2. In this case, what you will do is you will take a sort, you will sort the array. So 1, 2, 2, 3, 4, 5. After that you will find the prefix sum. So the prefix sum will be 1, 3, 5, 8, 12, 17, right? Now go through each element of the array. 2, how many elements are less than 2? So binary search here, binary search for the index of 2 here. So you will get, let's say this is the first index of 2, right? So what is the sum before this? What is the prefix sum before this? That will contain the sum of all the previous elements in the sorted array. That is all the elements less than 2, right? So again, like what does lower bound return? Lower bound will return in a sorted array. Lower bound will return the first index greater than equal to x, right? First index greater than equal to x. What do we want? We want the summation of all the elements smaller. So we want let's say lower bound is the index, so we want prefix sum of lower bound minus 1, right? Because that will be all the elements smaller than x, summation of all the elements smaller than x, that will be containing that, right? Similarly, so it will be 1. For 3 you will do a lower bound. Where do we end up? We end up here. So what is the prefix sum for the index before this? It is 5. So the sum of all the elements less than 3 is 5, which is true. 2 plus 1 is 5, right? Similarly for 4, where do you end up? You end up here. So the prefix sum before this is 8. So the sum of all the elements less than 4 in the array is 8. Why? Because 2 plus 3 plus 1 plus 2 is equals to 8. So pretty simple. Okay. Please adjust your mic. I'm not sure why. I think others can hear me well. Let me know if you guys cannot hear me. Otherwise, I think there might be some audio issue on your end. Can you check like if you have audio issue on your end? Can someone let me know if you guys can hear me well, or if there is some issue with my voice, like if you guys cannot hear me well? Otherwise, there might be a problem on your end. Okay, let's try to write the code for this. Pretty simple, right? So vector int temp equals to arr, right? We'll copy this here and then we'll sort temp dot begin, temp dot end. We can hear you. Thank you. Okay, so temp dot begin, temp dot end, will sort it first. After that what we'll do, right? After that what we'll do is, okay, we have copied this array in a temporary array, we have sorted it as well. Now we want to calculate the prefix sum. So let's first of all take n as well. N equals to arr dot, okay, n is already defined. Okay, so we need the prefix sum. So vector long prefix sum, and of size n, initially everything is 0. Prefix sum of 0 equals to temp of 0, right? And for int I equals to 1, I less than temp, I less than n, I plus plus, prefix sum of I is equals to prefix sum, sorry, prefix sum of I minus 1 plus arr of I, right? Prefix sum of I minus 1 plus arr of I. We are taking the prefix sum. Also, if you want to be a bit careful, what you can do is you can convert this to long as well into 1ll, and this will become a long, right? So you do long additions. After that, prefix sum is done. So after that, what we want to do is we want to do a binary search. So also we want to store the answers. So vector long answer for int I equals to 0, I less than n, I plus plus. Okay, so first is int index equals to lower bound. We want to search on the lower bound of what? Temp dot begin, temp dot end. And what do we want to search for? We want to search for arri, right? We want to search for arri, the lower bound, right? Now if, and also minus temp dot begin, definitely, to get the index. This will return a iterator. Lower bound returns what? Lower bound returns a iterator or a pointer. You have to get the index. Should be temp, not arr in prefix sum. Sorry, yes, it should be temp of it. So we have the lower bound. After that, what we want to do, we have got the index. So if index equals to 0, right? Index is equals to 0, that means there is no element less than this element, right? Because we are always sure, it will give the first index greater than equal to the element. We want the sum of less elements. So if it is equals to 0, that means there are no lesser elements, right? So in that case, answer dot pushback 0. Else index minus minus and answer dot pushback the prefix sum of index, right? Prefix sum of index and return answer. So that should be the solution. I hope I have not made any silly mistake. Sorted, we have sorted, we are taking prefix sum, we have the answer. Now I less than n, we'll take a lower bound here. Lower bound will return an iterator, so we do minus temp dot begin to get the index in the array. When we get the index, if the index is 0, that means there is no lesser element, so we'll push back 0, otherwise we'll push back the prefix sum. I don't understand what lower bound is. Okay, so lower bound is basically the first index. So let's write it down here. What is lower bound, right? Lower bound is the first index that is greater than equal to x. So when you do on a sorted array, if you do lower bound on some value, this is x basically, it will give you the first index that is greater than equal to x, right? So in our case, in the sorted array, what we want to find the sum of all the elements smaller than the given value. So what do? We do a lower bound on the array, right? So what we'll get, the index x, or the first index where the element is greater than equal to the given element. We want the element summation of elements smaller than that. So that will be, it is a sorted array, so that will be the previous element, previous index. So we'll do index minus minus and then we'll give the prefix sum. How to get lower bound in Java? There must be a collections method. Otherwise you can always write the code for this. Arrays.binary search might work. I'm not very confident with Java, like how it works. I haven't done a lot of CP in Java, so I cannot tell. Okay, so 140917, I guess that should be it. Yep. So let's try to submit this. Okay, so this also works, right? So this is the solution, pretty simple. Like the concept is entirely lower bound, right? And you, like, if you know about lower bound, this is a pretty simple problem. You just have to find the first index that is greater than equal to array. And in case you want to, like, if you don't have lower bound, right, if you don't have this method, you can always do a binary search. You can always write the code for lower bound. It is pretty simple to write as well. Okay, so it's just binary search, so you can always do that. I'm not sure, anyone who is comfortable, anyone who knows in Java, you can let them know in the comment what should be the equivalent to lower bound in Java. Anyways, you can let them know in the chat if is confident in Java, or anyone Java properly. Okay, so let's go with this maximum score ranges. Let's clear up. This is the, I think this is the problem where most of you got stuck, and actually it is very easy problem. Okay, arrays.binary search. Got it. Okay, so that should wait. So okay, so maximum score ranges, right? So you are given an array ARR of size n. Each element of the array contains a tuple of 3 integers. The first 2 integers denote the starting and the ending index of the ranges, and the third integer denotes the score you will get if you choose the range. Your task is to maximize the total score by selecting ranges such that ranges should not intersect. They can touch, but they should not intersect. So what is the question? You are given n ranges, right? You are given n ranges. Each range has a score associated with it as well. You have to select the ranges in such a way that they do not intersect. They can touch, but they should not intersect, and you get the maximum possible score. Why do we do index minus minus? Because we want the sum of the elements smaller than the given element. Lower bound will return the first index greater than equal to the given element. We want the smaller part. right? So we do index minus minus because the previous element will be the smaller element, less than a or a I. Do you solve these questions? I get the questions a bit before. I'm not given the solutions, but I get the questions a bit before. I already have solved them, or at least I've thought about them in most of the days. Anyways, so okay, so we have ARR. So we are given n ranges 5, 154, 1310, 355, 121, 232. Now 154, this tells us that the range is from 1 to 5. It has a score of 4 associated with it. 1310, it tells us the range is from 1 to 3 and it has a score 10 associated with it. 355 means the range is 3 to 5 and it has a score 5. 1 to 1, 2, 3, 2 accordingly, right? You have to what? You have to select the ranges in such a way they do not intersect and you get the maximum possible score. So the maximum score we can get is 15. How do we get? We can select this one 1, 3, 10 and 3, 5, 5. See, if they are not touching, right? So 1, 3, 10. Sorry. 1 to 3, there is a range. And after that 3 to 5 again, there is another range. So this score is 10, this score is 5. So then just touching, they are not intersecting. So you can take both of them and you get a score of 15, which is the maximum possible. Right? In fact, you cannot take any other because if you see, they will intersect. 154. Let's write it down here. 154. 1 to 5. And has a score of 4 associated with it. No point of taking this because this will intersect. Then there is 1 to 1, 2, 3. 1 to 1, 2, 3. 1 to 2 with 1 and 2 to 3 with 2. So you might have taken these two as well, but again the sum of them is 2 plus 1, 3, which is much less than 10. So it is better for us to take 1, 2, 3, 10, right? Let's say for this it was 3 and this was 6 and 4. In that case, it would have been better to take these two, 1 to 2, 2 to 3 and then 3 to 5, right? That would have given us the better cost. But in this case, in our case, it was very small, so we would prefer taking 1 to 3. So our range is 1 to 5 is equal to 1 to 3 and range 3 to 5. Yes. So 1 to 5, these are all independent ranges, right? And you cannot take 1, 3 and 1, 5 because they're intersecting. Similarly, you cannot take 1, 2 and 1, 3 because again they're intersecting. But you can take 1, 3 and 3, 5 because they are not intersecting, they're touching. You can take 1, 2, 2, 3 and 3, 5 because they are not intersecting, they are touching, right? So you cannot take intersecting ranges. I think the question makes sense. Okay. So let's look into the solution for this. So what we'll do is, so we have to maximize the cost, right? Whenever the problem involves some maximization or minimization, it's generally a DP question. It might be a greedy question as well. You have to identify whether you can do greedily or you cannot, right? But in our case, we see that can we do greedily? We cannot do greedily. We can always sort by the values, but it will become difficult for us to maintain. So how can we do it greedily? Let's think about a greedy solution. Maybe we can do greedily as well. How can we do it greedily? We can do it greedily as well. In fact, we can do it greedily, but the complexity will increase to n log n. Why? Because what we have to do is we have to sort with respect to their values so that we take the bigger values first. And after that, actually greedily might not work. Why? Because we cannot do greedily. I'll tell you why. Because here each of them has a value associated, right? So you cannot do greedily because let's say you have a 1 to 5 has a value of 20. So you would prefer taking this, but let's say there are two ranges, 1 to 2 it has a value of 10 and 2 to 5 it has a value of 15. So you can get a 25 value, but you will choose a 20 value if you choose greedily. So you cannot do a greedy solution, right? You cannot do a greedy solution. So this actually brings us to DP. So what we can do is let's think about a DP solution, right? So let's say DP of, let's say we are at index n, some index n, and yeah, DP index n. What will this tell? It is the maximum value we can choose from ranges starting at n. So maximum value we can choose from ranges starting greater than equal to n. So dp of n is what? Again, dp of n is what? Maximum value we can choose from ranges that are starting greater than equal to n. Like, so let's say, again, like an example, what is dp of 3? dp of 3 is the maximum value you can choose using the ranges that are starting at greater than equal to 3. That is the ranges 3 to 4, 4 to 5, 3 to 5. These will be considered. The range 1 to 2 or 1 to 5 will not be considered because they are not starting at greater than equal to 3. So dp of n is the maximum value we can choose from ranges that are starting greater than equal to n. What will be our solution? Our answer will be dp of 0. The range is starting greater than equal to 0. dp of 0 or dp of 1 will be our answer, whichever like is the whatever you want to do, right? So dp of 0 or dp of 1 will be our answer. But dp of n is this definition, right? Maximum value we can choose from ranges starting at greater than equal to n. Okay, now let's talk about the transition. So what we can do, we have the ranges. So this is dp of n. We have the ranges starting greater than equal to n. So for the ranges that are either we will not start, will not choose any range that is starting at n. Either will not choose any range that is starting at n. So in that case, we'll directly go to dp of n plus 1 because we want to choose ranges starting at n plus 1 or more than n plus 1, because we don't want to choose any range that is starting at n. Or if there are ranges that are starting at n, we might want to choose them. So in that case, dp of, let's call the right limit as right value, the r value, or the r value, let's call it r. Instead of right, let's call it r. dp of ri, you directly go to ri because let's say you choose a range L to R, then you cannot choose any other range in this segment. So the next point you should start at is R. So you will directly go to ri and you will add the value to this, right? You will add its value to this value of I. You want the maximum out. You want the maximum out. So the maximum of this, where ri comma vi are the right limit and value for ranges starting at I. Okay, so again let's understand this again, right? So first thing is we have realized what is the state, what is the definition. dp of n is what? dp of n is the maximum value we can get using ranges greater than equal to n. The maximum, yes, there might be multiple segments. I'm not telling there will be a single segment. There will be, that's why I use the notation I, right? There will be multiple segments. Maximum value we can get using ranges greater than equal to n. So what we are saying is, we'll take the maximum of, either we will not choose any segment. We will not choose any segment that is starting at n. So this means we do not choose any segment starting at n. We do not choose any segment starting at n. Or we want to, or let's say there are some segments that are starting at n, right? So we might want to choose them. In that case, we'll directly go, let's say we have chosen the ith segment. We have chosen the ith segment that is starting at n. Let's say there are k segments starting at n. Let's say there are k segments starting at n, right? So I is less than equal to k. We'll choose the ith segment. So when we choose the ith segment, we cannot choose, like let's say the range is from Li to Ri. So we cannot choose any other element in this range. So we'll directly go to Ri, and we have chosen this, so we'll get the value Vi. This will be added. So this is the recursion. This is the recursion. Okay. Let's understand this with an example. We'll just understand the state transition with an example, how this works. So let's say we have ranges 3 to 4 with a value of 3. We have 3 to 5 with a value of 4. We have 4 to 5 with a value of 3. We have 5 to 7 with a value of 6. Right. So let's understand this. So let's say we are at 3. So dp of 3. What is dp of 3? Either we can choose any segment that is starting at 3, or we will not choose. So it will be max of dp of 4, or we can choose the segment starting at 3. What are the segments starting at 3? 3, 4, 3 and 3, 5, 3. So let's say we choose 3, 4, 3. So in that case, it will be, we'll directly next search at 4. We'll search at 4 because we cannot choose any range between 3 to 4. We have chosen this one, and we add a value of 3 to this because we have chosen this. Or let's say we choose this one, 3, 5. So in that case, next position where we start selecting is 5, and we get a value of 4. Right. So let's actually draw it in a tree fashion. That will make more sense. So let's say dp of 3. I am not getting anything. Then you have to work on your dp. Not my problem. You'll have to work. I'm trying to explain my best possible. And it's simple knapsack as well. Like there's nothing like rocket science in this. So you have to maybe practice dp a bit. So you will choose the max of what? Either you will not take any range that is starting at 3. That means you will not take these 3, right? So where you will start at? You will start searching from 4, the next possible position, or you will take some range that is starting at 3. So you can take this one, 3, 4, 3. It is starting at 3. Yes. So next, where do you start searching from? You start searching from the right hand part because you cannot take any range in between. So you will start searching from 4, and you have got a value of 3 here. Or you can take this one as well. So in that case, you start searching from where? 5. You start searching from 5, and you get a value of 4 with this. Right. Now coming to dp of 4. dp of 4, again you have the same choice. Either you will not choose 4, so you will go to 5 directly, or you can choose some range starting at 4. How many ranges are there starting at 4? One range is there, so let's choose that. If we choose that, where do we end? 5. So we'll start searching from 5 again, dp of 5, and we'll get the value plus 3 against this. Right. So dp of 5, there is only, you can take you have to take this again, like there is no other range here, although you have a choice, but again there is no other range. So let's just assume we take this. So you dp of 5 is equals to 6. Let's say dp of 5 is equals to 6. So we return 6 from here. This will become also 6 because it is we have dp of 5 equals to 6. So 6 plus 3, 7, 8, 9. So it will return 9. Now which one is the maximum? 6 or 9? 9 is the maximum. So dp of 4. So this is 4, let's say this is 5. 5 is value 6. dp of 4 becomes 9. dp of 4 is 9. So it will return 9 as the answer. Now here we have again dp of 4. So dp of 4 we already have computed to be 9. We don't need to compute again. So we'll return 9. And dp of 5 we have already computed to be 6. So we will return. So 9 plus 3 is 9, 10, 11, 12. Sorry, we have not added the plus 3. So 12, this will return 12. This will return 6 plus 4 is 10. So which is maximum? 9, 12 or 10? 12 is maximum. So dp of 3 becomes 12. This should return 12. And in fact 12 is the answer, right? You will choose this one. You will choose this one. and you will choose this one. What is the value that you get? 3 plus 3 6, 6 plus 6 12. All right, so this is how this works. Okay, so let's try to write the code for this now. And yeah, like dp of n, the last element will be yeah, like the last index will be 0 or something. So let's try to write this. And arri is also within n. Okay, cool. So one second. Arri is less than, so long dp. I hope everyone have understood this. So long n plus 1. So fill dp plus n plus 1 and 0. Initially we'll fill everything with 0, right? So first of all, we have to know how many elements are starting at index I, right? How many ranges are starting at some given n. So for that we'll maintain a map. So map of, rather we can maintain a vector as well. So vector int ranges n, and also we need a paired actually, because we want to maintain their values as well, right? We don't want to just maintain the range, we want to maintain the values as well. So ranges n plus 1. For int I equals to 0, I less than n, I plus plus. Int l equals to arr I0. Int r equals to arr I1. Int v equals to arr I2, right? So we have this. So now ranges of l dot push back for this position will push back what? Will push back r and the corresponding value v. How to get to know we should apply dp? So generally the idea is that you have, when like what questions does dp solve? Generally you will have question like you have to find the number of ways, you have to find the maximum value that you can get, you have to find the minimum value, like minimization, maximization, counting the number of ways. They generally tend to be like dp problems. Now there will be a confusion between dp and greedy, but if you see, greedy will not work. I have already given an example, right? Just assume a range 1 to 5 with 20 value, and two ranges 1 to 3 with 10 and 3 to 5 with 15, and it is better to take the smaller weights than the greater weight, right? So greedy will not work, so that actually leaves us with dp, right? So kind of like that. Ranges of l dot pushback rv. Okay, now what we want to do is, we want to process, like if we see our recursion again, like let's see our recursion once. Our recursion is going forward, right? Our recursion is going forward, like from dp n we are going to n plus 1, n plus 2, like that. So our loop should be running backward, because before we calculate I plus 1 should be calculated, so the loop should be running backward. So for int I equals to in fact let's make it n plus 2 plus 2. For int I equals to, sorry, dp of plus 2. Yes. For int I equals to n, I greater than equal to 0, I minus minus. So dp of I equals to, initially will initialize with dpi plus 1. Now for all the ranges, for pair intent range belonging to the ranges of I, what we'll do is dpi equals to max dpi, or we'll choose this range. So dp range dot first plus range dot second, that is the value, right? We have ranges will be what? Of the form r and v, the right hand limit and the value. So r range dot first is the right hand limit, and range dot second is the value. So r dot second, right? And finally will return dp0. that should be it. And yeah, ranges plus ranges dot second into 1L. Let's do that so that we do not have proper. Should we update ranges array size to n plus 2? Not needed. Ranges will be within the range 1 to n, right? Ranges will be within the range 1 to n. I have updated the DP array to n plus 2 because here at I equals to n, we are starting at I equals to n. So DP I equals to DP I plus 1. So it will access DP n plus 1, which is 0, right? So that's why I have made this n plus 2. Why vector pair? Vector pair because we want for each index, we want the ranges, right, that are present. What do we want from the ranges? We want the right hand limit because left hand limit is already like where it is getting stored, the index, right? The right hand limit and the value is what we want. So that's why pair intent. We want to store two values. That is the right hand limit of the range and the value. So that's why we have taken pair. Compile and run. Let's see if this is working. So we get 8. If that's the right answer, but okay, so this is also working fine. I hope this is clear with everyone. Anyone has any doubts with this? The code is pretty simple, like simple way to do knapsack or something like that. But yeah, like just the intuition is that you have to, for the L values, you will just store the R values and the V values, and that works. It's difficult for me to paste the code. So if because YouTube is not open, it is open in my mobile, it is not open in my laptop, so it will be a bit difficult. So just like whenever network works, just rewatch the video, note down the timestamp, like what is the current timestamp, and just come to this. How to solve this if ranges can be? That's a good question. So Tapan has asked a very good question. How to solve this question if the ranges are of length 0 to 10 to the power 9? Can anyone tell how to solve if the ranges like L and R values are of the range 10 to the power 9? The time complexity is order of n, right? Order of n because we are running a single loop. Can anyone tell what happens, how to solve this question when L and R are of the range 10 to the power 9? Binary search, okay? Anyone? Maps, okay. So no, actually we don't have to use maps as well. We can use maps, but again this DP will not work, right? So whenever you see the ranges, I'll tell you a trick here. This is very interesting. I'll tell you a trick here. Let's write it down or let's draw it down here, right? Let's use the whiteboard. So this technique is called, I'm pretty sure many of you already have heard of this, but this technique is called coordinate compression, right? This is called coordinate compression. What it tells is that, let's say if you have ranges of the range like 10 to the power 9, L and R values of the 10 to the power 9. But how many ranges will you have? The number of ranges you will have is of the order 10 to the power 5 only, right? It will be of the order 10 to the power 5. What is the point of interest? If you look into it carefully, you do not care about, like when you have a range L to R, you really do not care about L plus 1, L plus 2 up to R minus 1, right? Your point of interest is only L and R. So how many distinct values of L and R we get? If we just store the points of interest, these are called the points of interest. If we just store the point of interest, how many points of interest we'll have? So we will have 2 point of interest per LR per range. There are 10 to the power 5 ranges, so 2 into 10 to the power 5 points of interest. So essentially we can map each point of interest, to some integer of the range 2 into 10 to the power 5. we can map each integer. So basically, let's say something like we have ranges like this: 1 to 5, 2 to 4, and 100 to 1000. So what we can do, 1000 is a small here example here, but what we can do is, what we'll take up the unique values here. So what are the unique values? 1, 2, 4, 5, 100 and 1000, and we'll map them correspondingly. So 1 becomes 1, 2 becomes 2, 4 becomes 3, 5 becomes 4, 100 becomes 5, 1000 becomes 6. And now see, we can actually do all the computations. So right, so one second, Aditya, I'll come back to you, 1 second. So this is called coordinate compression. Basically, you are compressing the values. You are compressing the values from 10 to the power 5 range to 10 to the power 5 range. And this is a very powerful technique. Whenever you have ranges of the order 10 to the power 9, you can always come back to this technique, right? Okay, so let's quickly, last question I'll take from Aditya. What he has asked is, why, like in my recursion, if you remember, what was the recursion that I had written? The recursion I had written was dp of n is equals to max of dp of n plus 1 or dp of ri will take a range plus vi. This was the recursion. Now, why have we not taken that here, n plus 1 here? We have already taken that, right? The first condition that I've done is we have already taken n plus 1. dp of I is dp of I plus 1. We are initializing with this and then we are comparing. Now, dp of I in the first iteration has the value dp of I plus 1. That is dp of n plus 1. And after that, it is comparing like this, right? Yes, n log n for sorting. We need n log n. We need that complexity for maps and for storing the values for sorting and maps. But in n log n, you can actually solve the problem. Left some till, nay, the question was pretty clear, right? The question just asks you, find the sum of the elements that is less than ARR of I. Just simple, कुछ सोचना नहीं है. Sum of elements less than ARR of I. तो अगर sort करोगे, if the array is sorted, what are the elements less than ARR of I on the left hand side? तो वही करना है बस. Cool. Is this clear with everyone? Clear with everyone? How to solve it when the ranges are of the order 10 to the power 9? You can use coordinate compression. You can just compress all the values from 10 to the power 9 to 10 to the power 5. You have to solve more questions. Just give on giving the contest, and after the contest, after we discuss the solutions, you should always try to write the code yourself, right? Because when you write the code yourself, irrespective of how good I explain or how bad I explain, irrespective of that, whenever you write the code yourself, you understand it better. So everyone should always make it a habit. After the session, write the code yourself. Okay, cool. So I'll be seeing you guys in the next class. Thank you for joining.